Okay, Chapter 3, Lesson 3, Graphing Linear Functions. In order to graph a linear function, the function must be in the form of y equals mx plus b, where m is the slope and b is the y-intercept. If we have it in the form of ax plus by equals c, this is called standard form. This last one was called slope-intercept form. Then, if we let x equal 0, we can solve for the y-intercept. And if we let y equal 0, we can solve for the x-intercept, or the place where the equation crosses the x-axis for the x-intercept, or the place where the equation crosses the y-intercept axis for the y-intercept. So we're going to be working on graphing out of these two different forms. So this first whole page is graphing out of slope-intercept form. So when I'm looking at y equals 2x plus 1, I know that my slope, or my m, is 2. And since I'm doing slope, I want a fraction, so I'm going to do 2 over 1. And I know that my y-intercept, or my b, is positive 1. So when I come over here to my graph, I always want to start at the y-intercept. So my y-intercept is 1, and I'm actually going to write it as a point because it's a point on the graph. So it's actually at 0, 1 is my starting. So I start here. And then my slope tells me how to move. So my slope says go up 2 over 1. And that would be the graph of y equals 2x plus 1. Okay, for the second one here, I have y equals 3x, and there's nothing behind it, so I'm going to put plus 0. So my slope is 3 over 1, and my starting point, my y-intercept, is 0, 0. So I start there, I move up 3 over 1, and there is that graph. Oh no. Erase the whole thing. Okay, for my third one, I have y equals negative 1/2 as my slope, and my y-intercept is 0, 7. So I'm going to start at 7. And this time my slope says go down 1 over 2. Down 1 over 2. Down 1 over 2. Down 1 over 2. And if you have an equation where your slope is negative, you know that your graph should be going down from left to right. Okay, when our equations are in standard form, what we're going to do is we're going to cover each opposite letter to find the different intercepts. Once we have the two intercepts, we can plot them on the graph, and then we'll be able to graph our line. So if I want to solve for the x-intercept, I need to cover the y. And it tells me that my x-intercept is negative 4. And since it's on the x-axis, it would be negative 4, 0. To solve for my y-intercept, I'm going to cover the x. I'm going to divide by negative 1 on both sides to get the y to be positive, which makes my negative 4 become a positive also. So my y-intercept is 0, positive 4. So my x-intercept is at negative 4, which is here, negative 4, 0. And my y-intercept is 0, positive 4, which gives me that graph. On my second one, when I cover up my y, it gives me 2x equals 2. So when I divide by 2 on each side, I get my x to be 1. Then when I want to solve for x, I cover up, or for y, I cover up the x. Divide each side by -1, which leaves me with y equals -2. So I come over here and the x is +1, the y is -2, and there would be that graph. On the third one, I cover up the y to solve for x, and that would give me x-intercept as 3. And then for the y-intercept, I cover up the x, divide each side by 6, and that would give me a y-intercept of 2. X at 3, y at +2, and there would be the graph of the third one. Now, something we have to remember, sometimes we are given equations of just one variable. So the first type would be if you're given the equation y equals a number and there is no x. So in that case, it's a horizontal line. So if there's no x. So if I have the equation of y equals 5 from down here, there is no x, so I don't want it to cross the x-axis. So I go up to y5, and it's going to be a horizontal line. If I have just x equals a number, that's a vertical line. So for the example, x equals -1, I just come over here on the x-axis at -1, and it won't cross the y-axis, so it'll just be a vertical line